useful. So I don't really want to say too much about us, just the fact that Dave and I do AppSec on a daily basis. So we've reviewed a lot of applications, a lot of mobile applications as well, which is where we kind of draw some of these experiences from to include in this talk and what's been useful to us. So jumping right in, what is runtime analysis? So if this is kind of a term that we use for for security testing, but essentially we're debugging applications, right? Now this is very useful in a scenario where you're testing an app that may use some custom protocol. Mobile fit clients can use whatever they want, right? Maybe raw socket connections, maybe the app has some funky custom crypto over the wire, and you want to get in between that traffic and manipulate some of the requests, right, to do your testing. And just a straight proxy is not going to work there. So it's really useful in those type of scenarios where we want to get inside. I'm going to start with Android, and then we're going to talk about how that works and how it's a little different than how you might apply some of this for iOS. So Android, my experience has been that it's most effective to do this type of testing with an emulator, and the reason is that the emulator is going to start up apps in a debuggable state by default. There are some ways you can try to do this from a device, but unless the application is built in such a way that you have to run it on a device, in most cases it's easier to do the testing on the emulator. So there are some ways you can kind of, if you've downloaded an app from the marketplace and you want to test it, or you just have an APK, it's pretty easy to get that onto the device to do your testing. As far as the tools that are available to do runtime analysis, there are quite a few more, and it's more robust on iOS. As far as how we do that in the Android space, it's essentially just a Java debugger, right? So JDB is one, for example, ships directly with a JDK. If you've got a JDK installed, you have JDB. It's command line debugger. Most of the debuggers, however, are built for developers, so it's not the most robust solution today. However, this may change going forward. As of right now, it's a little bit clunky to do this type of testing. So you'd use JDB, and you can do a whole bunch of stuff here once you've set up an app in a debugger. You can invoke methods, you can modify variables within the methods, you can call methods directly, right? You don't have to just say, hey, stop here, I want to target this method, and then change some things. Once you hit a breakpoint, you're in the Java VM, or you're the Dalvik VM, and you can call off whatever functions you want. So just as a couple of resources, and again, you can pull these out of the slides from the PDFs. If you've got an app and you want to get it off of your device, you can suck it off of there pretty easily. If you need to test on a device, there are some methods. I've heard of these working for some people before. I haven't gotten them to work very well, but there are some methods you may try to use if your device is rooted and you want to try and get an application in a debuggable state so you can attach to it. I really want to go ahead and show how the attaching works and what you can do and the power there. Here's kind of just a quick diagram of what the connection and state looks like, right? So if you've got an application that's running on your device or in the emulator, you can use ADB to tell the, to forward a debuggable port into your host machine so that you can attach to it with any type of debugger. And I'll use JDB in this example because it's the best one that I know of to do this, right? So most of the debuggers, like the Eclipse debugger or the graphical debuggers, expect to have source code, which if we're doing a black box penetration test, we're probably not going to have. And if some developer has shipped us their source code, we may have a hard time building it and launching it ourselves, right? So this is basically how the workflow looks, right? So you attach to the debugger. ADB is going to be forwarding the appropriate ports for you. Now, I will add some caution here. I've had some difficulty with this. It appears that you can only attach a single debugger at a time, and you're not really going to get a useful error if there's a problem with that. So for example, if you have Eclipse up and running in the background because you've loaded up the code or whatever separately, and you've got the SDK tools installed, DDMS is running in the background and attaching and looking for devices or an emulator that may be running, and that's going to clobber you if you try and attach, right? And Android is just going to say, I couldn't attach, and you're not going to get any useful output there. So if you run into this problem, just make sure you've only got one thing running. You're not, you don't have multiple services running at the same time. So I'm going to try and demonstrate some of this, and hopefully it goes off okay. Got the wrong window up, of course. So I'm going to drag the, I have a virtual machine here that is running a Android emulator. This is a app that the Security Compass team has built. It's called Fault Secure Mobile. So it's intentionally vulnerable Android application. This is open source. There's also an application for iOS if you don't have anything to try and test out with, or if you're looking for an app to test your mobile hacking skills, this is very useful. Pretty vanilla as far as what you can do with it. It simulates a banking application. You can log in, perform transfers, and view information about your account. So if I were to perform a transfer, I would select the amount that I want to send, and it works as you would expect, right? So for the purposes of this demonstration, we're going to pretend this is, it uses HTTP. I'm going to pretend it doesn't use HTTP. This may be some raw socket, and I want to manipulate that transfer request, right? So I want to see if I can change maybe any information in the middle of the request, maybe the account that the money is transferred to, or something along those lines, and we'll see how we can do that. So just a couple of quick commands, and it's going to be a little clunky since I'm typing over my shoulder, but realistically in practice, I think the way you would apply this would be, if we're doing a black box test, we're probably going to decompile the code, right? Android code is fairly easy to get back to a readable format of the code in Java or one of the intermediary formats like Smalley. I can show some of that if we've got some more time towards the end of the talk. Has anybody tried to decompile Android code before? Yeah? Okay, so the tools available to do it are fairly robust, and they work well today. And realistically, we're going to have decompiled the code. We're going to try and get some idea of what classes exist in the application, what methods exist in the application. And so I've identified this target method right here that I want to try and stop, the transfer funds method, right? So I'm going to go ahead and open up Eclipse. I know that I have DDMS running already. It's going to just show me what ports. It already forwards some debugging ports for applications. So every app that's on the emulator, it's set up a debug port for already and forwarded to my host. If you want to do this manually, there are some ADB commands, like I mentioned, to set this up. But we're just going to go ahead and use this. So the Fault Secure Mobile app has a debugging port on 8612. And I'll copy my little command here. JDB-attach. Look, 8612. And now we have a terminal debugging session, right? And you can type help and get all types of useful information. One of the interesting commands is the classes command. Now that's going to show you every single class that's loaded in the VM, right? And it's really a lot, and there's not a great way to filter this in JDB by default. So again, this is why I mentioned realistically, the way I think this is applied in practice is very targeted, right? You've already decompiled. You know where you want to try and manipulate something. So let's use JDB to try and help us do that. So at this point, we're going to go ahead and maybe I want to see some information about this class that I've identified, right? So I can have it show me all the methods that are defined in that class by using the methods command. So I may say methods, space, and then the fully qualified name of the class, and it'll print out a whole bunch of information. I'll show in another moment after we actually stop the request that you can see some of the fields that are set. So if we want to see, for example, what the current session key is for the server, or if the user's password is in memory, how we might do that. Let's go back here, and I want to actually stop that request. So I will use the stop in command and the fully qualified name of the method, and that'll set a breakpoint. Again, in these slides, I'm going to include some resources. There's lots of great documentation on how to use JDB. I'm interested if there are other, I've searched for some other graphical debuggers if they exist that don't require source code, but those options seem kind of sparse today. So I'm going to leave this terminal in the background, and if I go ahead and start a transfer now, it should break on that request. So I'll set it for 1, and we've hit a breakpoint. If you use the where command, you can get the full stack trace of execution. So for example, if I'm reviewing this app and I know where the event happens, but I'm not really sure how it got there, you can use this information to help reverse and understand what's going on inside the app. Another interesting command is the locals, which will show you all local variables passed to this method. So you see there's a from account, a to account, and an amount specified here. So you can actually say set amount equals 5 or something along those lines. And if I use locals again, it will show me that the amount has changed. And pressing continue will allow that to fire off and go ahead through to the server. I actually have a proxy set up right here, so we can turn intercepting on. And if I know the entire format of the request, I can just go ahead and evaluate the method directly. So I may say, for example, just eval the transfer funds method because that's available within this context for the amount of $800. And we should see now where that's stopped in the proxy before it gets to the server. So we see that there's an $800 amount now going to the server as part of the request. And you can manipulate any of those other parameters as you see fit. Now, normally testing this application, I would just be using the proxy because this is far easier, right, since it's using HTTP. All right, just another couple quick examples of what we might do here. If I want to view, wrong terminal. If I want to view information about the current class that I stopped in, I can say something like dump this. And it will print out a whole bunch of information related to the variables that are set or the constants within the class. And you can actually print some attributes directly. So if I know that there's a session key attribute, that may be very useful to me as far as testing. Maybe I've built some curl script outside of the app, and I just need to get an updated one. So I can print it out right there. This has proven very useful for me in very complex, convoluted apps. For example, if there's crypto involved, right, and I want to, like, I've sucked the data out some other way. Maybe it was stored on the device, on the file system, and I know the method of encryption. I just need to get the current key so I can decrypt that data. I can pull it out in this way. So this has been very useful. All right, so with that, I'm going to hand it off so we can talk about iOS.
So Dan talked a little bit about Android. iOS obviously is a little different, but there are some really good tools to be using when performing runtime analysis and memory analysis. I've highlighted a couple on the slide here that I'll show you demos, hopefully, with SideCrypt and Snoopit. Has anyone used those? Couple? So both of those allow you to attach to a running application just like Dan did, so it's basically debugging. But as you can see, one of them is a little bit more user-friendly and the other one's kind of command line, right? So I'm going to try Snoopit first, But this is Snoopid. So Andres Kurtz created this. You may have seen him in the news. He's the one who found that email wasn't really being encrypted. But he created this Snoopit. It only works on the non-64-bit architectures at this point, but he said he's working on it, so it'll work on those. Lots of features of Snoopit built right into the tool. So as you can see here, it's a web interface, right? So I just browse to it. It's all loaded on I have a jailbroken iPad here, and I'll try and bring that up here in a minute. But you can look at file system access calls, keychain. You can turn on method tracing. So that's really neat. If you really don't know what you're looking for, but you know the function in the app, if you go to the app and try to do that function in the app, you can turn method tracing on and see exactly what it's doing. Based on each method, you can see memory addresses, values that are being passed to different methods. It's really, really neat. You can look at debug outputs. You can fake information, right? So if it's using UDID, you can fake that. You can fake location. So a lot of apps I look at are based off your location. So if I fake it, like say this app can only be used in Australia, if I fake my location to be in Australia, then I can use the app. So it's a very, very powerful tool, and I'm going to try and demo it here. We'll see how that goes. All right. So here is what Snoopit looks like. And you can set up authentication. Obviously, it's just basic auth. But I'm connected directly to my jailbroken iPad. And I've got a little screenshot of it here. So this is an app called PhotoSafe. Securely store your photos, right? We'll see about that. Most of the photo apps that are supposed to be secure are vulnerable to this. But anyway, so this is Snoopit. As you can see here, there's quite a few different things, and the one thing that you're really going to go toward is Objective-C classes. These are all the classes, the ones that are loaded and the ones that are not loaded within the app. There's quite a few of them. Anyone see anything on the screen there that looks interesting? That might be interesting. Sorry about the screen. So what that does is it prints out all the different variables, functions, and everything else, and it allows me to select and possibly even, here let's see if this works. Nope. Invoke it, if I can see it. There we go. Bring it back here so I can see it. So as you can see here, there's a setup and invoke. So I selected the method that I want to invoke. Dismiss lock screen. See if I can do this. So what that does is it pops up a little box here. And if it requires parameters, it will actually request the parameters from you. This is just a void. So I can invoke it. And voila. We've now bypassed their lock screen. And I can view the secret photos. So that's just something you can do with these tools, especially for those apps that are doing things like local authentication. Sometimes I look for that. We'll talk about some memory analysis in a little bit. That's another thing that is nice and useful with Snoopit. I highly recommend using that. So that to me is a little bit easier because it already does most of the hard work for you. Prints everything out nicely, the classes and everything. Now, if it will show. PowerPoint.
PowerPoint, please open.
Yeah, open PowerPoint. Okay, let's get back to where we were. So that's Snoopit. So Cycrypt. So this one's more of a command line debugger. Again, with both SciCrypt and Snoopit, you need a jailbroken device. It has to be a device that will not work on the simulator. And I wouldn't recommend testing any iOS apps on the simulator for good reasons. But SciCrypt allows developers to really explore, just like Snoopit, but they can do it with a command line. Snoopit makes it a little bit easier, but there's syntax highlighting. It combines a bunch of things. iOS execution flow is very important if it will remain open. Here, how about we just do this? Or not. We lost connection. There we go. So the iOS execution flow is kind of important. Those of you that have developed in C, C++, Objective-C is just a superset of C. So all execution begins with a main function, and that's no different here in iOS. I'm not going to go through the flow. We don't have a whole lot of time, but this is a good picture to look at. Download the app and follow that. You'll need to understand that if you really want to use SciCrypt and understand that how the different view controllers work, the app delegates, and so on. So SciCrypt is really a programming language. It's written for you to use JavaScript and Objective-C, and you can combine them when you're programming to go against that runtime. It allows you to hook right into the application just like Snoopit does, and it grants access to all the classes, functions, methods, parameters, and you can write and execute scripts. But again, it's only available on jailbroken devices. That's a key here. It's not something you can install on non-jailbroken devices. It's easily installable through Cydia, which I'm sure most of you who have done any testing at all have used in the past. So why? We kind of showed you why with Snoopit. You can bypass a lot of client-side validations. You can look at memory, right? So if someone's storing some sensitive data in memory for maybe too long, it's probably good to make sure they know they should remove that from memory. You can overwrite methods, perform method swizzling. That's pretty neat, especially if you're looking at an app that does root or jailbreak detection. You can just tell that method to always return, no, it's not jailbroken. So that allows us to kind of bypass that initial check so we can then attach the app and do other things. So here's some quick usage. I'll show you hopefully here in a little bit too. But basically, you just attach right to that running application. You can attach to it by process ID or by name. It's pretty simple. You just have to SSH into the device that you're trying to test from. So here, I've got a little PS. So obviously with SSH and iOS, you can use PS, get the process ID, and connect to it. And here's, every app has the UI app and delegate. And right here, when you request that, it returns the memory address if that's been loaded or initialized. And remember that because I'll show you here in a little bit why that's important. So one command that's interesting is the Objective-C.classes. It will dump every class in the app you're attached to. Kind of like Snoopit, but it's a little bit uglier. It's just a big string of a bunch of classes, so you kind of have to parse through that, maybe put it in a text pad. But the problem with it is if the classes list is way too large, a lot of times it just kills the app. So that most of the time is no good. So that's why I like to use Snoopit and SciCrypt kind of back and forth, because I can find what I'm interested in and kind of analyze it a little bit further with SciCrypt. So you can get memory addresses with the choose command. I use this all the time. If you know the class name, you choose class name, and it will return any of those class names that are initialized and give you the memory address. And that's important because now I'm going to set a JavaScript variable as a new instance to that memory address. So now I have a variable that's pointing right to that memory address, which is actually the some class, right? And then I can perform commands on it like I would in Objective-C, right? Some class, some method, possibly some parameter. And that should work. So there's a bunch of common functions that are used in SciCrypt. So when you load SciCrypt and attach to that running app, You can also load common functions. Now you could just type these in the SciCrypt command line interface, but it's a lot easier just to put them in a big long script file and load that when you attach to the running process. So here I use most often is try print ivars, print methods, and methods matching. So those are very important. Print methods I use most frequently, so I know what methods are going on in the class. If it's a very, very large class with many, many different methods, I can look for specific methods matching using regex. And these are available online. iPhone Dev Wiki. It's a pretty awesome resource. Definitely check it out. Method swizzling, I did mention that a little bit. Unfortunately, we won't have enough time to show it today, but it's fairly simplistic. Every class you can dump messages, which will dump methods, it'll dump variable names, it just dumps everything it knows about that class. So if I find a class, so like the get password view controller, I know the method is dismiss lock screen, right? I could change the return to that, right, by this nomenclature here. Some class.messages, whatever the method is, equals function return true. So I'm just setting it to a JavaScript function, and that's how we bypass jailbreak detection most often. It's fairly straightforward. So let's try a little SciCrypt. Oh, one thing to note, if you're using SciCrypt and Snoopit, they can't be used simultaneously. They get confused and the app crashes all the time. So make sure and kill Snoopit on the iDevice before you try to use SciCrypt, because a lot of times it just won't attach. You might want to kill the app too and start it up again. So I'm going to do that quick. While I get ready here. Okay, so I'm attached through SSH. Got to make sure PhotoSafe's running. And if you want to get a process list, AUX works. I use EF as well, maybe grep. So I can find the app name or process ID. I usually use the app name. Sometimes it's easy, but this one's fairly large. So then I can attach to that. And here I'm going to add those scripts that I showed you. So I have them in a .sci file on the local iPad, obviously. And in one command, I can now attach to, hopefully. So now I'm attached to my PhotoSafe app. Okay, so let's try the ugly Objective-C.classes. Hopefully this doesn't crash the app. It does take a little bit sometimes, and you'll see why you might want to use Snoopit instead here in a second. Maybe. No, it's not crashed yet. There. That's why you probably want to use Snoopit, especially if it's a very, very large app with many, many different classes, but they're all there. So if you can get that into a text editor or something and parse through it and look for what you're looking for. But again, a lot of times that does crash the app. Since we know what we're looking at, the great thing about SciCrypt too, it's got tab completion. Awesome. On the methods even too. So I'm going to choose that. It's got a memory address. Go ahead and copy that. And I'm going to create a var. And assign it to that memory address. And then I can try, let's get our, see if I still have this running. That's my iPad. Just like that. So again, you can see why I use both of them, but the one thing I do like about SciCrypt is it's a little bit easier to go after specific iOS APIs. One I like to look at is the UI text field. So I'll do a choose on that. And the nice thing about that is it prints out everything it knows of in any that's been defined in any UI text field. This is a great place to find passwords and things like that. Another one I like to use, choose on, is NSString. This one's a lot uglier, but you're going to find a lot in that as well. So you're going to see a bunch of these to Scion. That's a SciCrypt built-in thing. Some of it's memory addresses, but at some point you'll find some of that sensitive data you might be looking for. So that is SciCrypt, or at least part of it. Let's see, we got changes here, but not there.
Yeah, so the SciCrypt interface is far more useful than JDB is, but the one thing I will say is that JDB uses the standard Java debugger protocol, JDWP, and there's a spec. It's fairly well documented. I think if there were some scripts that you specifically wanted to write to do testing, it would be moderately easy. And I don't want to trivialize it, but it is possible. Sun even has an unexposed API to interface with the JDWP protocol. So you could use that if you wanted to attempt to automate some of this data extraction or testing things that you're trying to do within an app.
So another thing we do with the same tools is analyze memory, right? I think that's very important since we're talking client-server apps, really, right? It's sure it's on a mobile device, but it's a client-server app, and there's a lot going on the client. Whether or not they're actually storing anything locally on disk doesn't necessarily matter. Even if they're storing it in memory, we can get at that with these tools and these tool sets. So we need to make sure that we're removing that sensitive data from memory, and we need to know if it's there. I kind of showed you how you would do that with the iOS tools, with SciCrypt and so on, and I'll let Dan kind of explain Android.
Sure. So Android, if you want to dump the memory for an application, it's fairly easy to do. Inside of Eclipse, you can, if you're using DDMS, there's an option to export a HProf file. Now, I'm going to show some of this. I don't know if we'll be able to do an entire demo because we want to leave some time for questions. However, inside of here, if I select an application and I just go up and say dump me an HProf file, it gives you an option to export it anywhere within your machine, and then you can use any typical memory analyzer to go ahead and look at the output. So the one thing that you have to do is convert it because Android uses a custom HProf format. Now they do ship a tool with the Android SDK tools called HProf-convert or -conf. And it's in the SDK tools directory, and you just point it at your HProf file, and then open it with any typical memory analyzer that you use. One that comes directly with the JDK is called JHAT. If you've never used this before, it'll start up a web server, and then you can click through the different classes that are loaded and look at different fields. There are a bunch. There's the Eclipse memory analyzer as well.
So I kind of mentioned memory analysis in iOS. It's back to Snoopit and SciCrypt, but really SciCrypt, because if you want to look at memory, a lot of times it's down at the lower level iOS APIs, and you want to get at those methods and those classes. So I would use SciCrypt for that. Like I said, NSString, the UI text field. Now sometimes applications override those, but again, that gets back to looking at Snoopit or SciCrypt at those methods. So that's why I use them back and forth. I haven't run into too many apps where they don't work. SciCrypt, I haven't run into any app that it doesn't work, but sometimes the Snoopit interface, something with the way they're connecting to that running app doesn't work. but SyCrypt's usually there. And SyCrypt actually does work on the 64-bit architectures, so you can at least use it on your iPhone 5S's and so on. Real quick, don't have a whole lot of time. We'll try to fly through this. iOS binary analysis, not easy, not straightforward. Obviously, you can't decompile iOS code. You can use some tools. Hopper app is pretty neat, if anyone's ever looked at that. Or they can spend a lot of money for IDA Pro. Either way, they'll allow you to at least look at and analyze that binary in a hex way. Obviously, IDA is going to be better, but it is fairly expensive. And these are just kind of what they look like. This is IDA Pro here in the foreground, and then the Hopper app in the back. Lots of other tools that I might use. I love strings. Anyone use strings? Probably the best Unix tool ever, especially when you're looking for certain things like keys, passwords, and whatever else. Just run strings against the binary and see what the output is and parse through that. Any sort of hex editor, hex edit's free. You can even edit, which may work. If you need to really look at and decrypt the binary, you can use Clutch. That doesn't always work. Again, that's a tool you can download from Cydia. It's just a different repo you need to add. Class dump will, if you finally decrypted the binary, you can use class dump to dump all the class information. This is really not something I would do all that often because I have SyCrypt. It does all that for me as it's running. But if you can't get those tools working, you have other options. And then Android.
Yeah, in Android there are a lot of tools available as well, right? And so, if you've done any Android decompiling before, you've probably heard of some of these. APK tool is a great tool. You can unbundle APKs, look at the resource files. APK tool uses Smalley under the hood. I'll show an example of maybe what some Smalley output looks like, but it will give you a representation of the class file and the code. I particularly like dex to jar as far as analyzing what the Java code might look like, right? So Smalley, if you've used Smalley before, you'll notice that it gives you a representation, right? And the point is that it's not Java code. It's like halfway in between dex code and Java code, right? So for me, that's kind of hard to read. Has anybody used JD GUI, Java decompiler? That's awesome if you're doing any type of Java application analysis, thick client. Any jar, it doesn't have to be an Android app, right? So you'd use dex to jar, and you can get a jar file you can open in JD GUI and look at Java files. And it's 90–95% of the time it's going to work for you. Every once in a while there may be some piece of code that it can't get all the way through, and you'll get that intermediary kind of Smalley output. Right, so these are some good resources for that. I have some mixed feelings about obfuscation, right? Some apps may be obfuscated, which make them harder for us to pile through from a testing perspective. So from a defense in depth aspect, I normally recommend do it, right, as a developer, because why not? In theory, if we're designing our apps correctly from an architecture perspective, it shouldn't matter. We shouldn't be hiding things within the client app that might be secret, right, and need to be obfuscated. But it's possible you run into some apps that are obfuscated, and that may make it difficult to go through this process. I'm sure it's impossible to see on the screen up here, but here's some example of Smalley output. You see kind of like the structure is like a source file, but it's not straight Java code. JD GUI will give you an interface like this. JD also has an Eclipse plugin. If you happen to be doing, want to see some jars that are already in Eclipse, you can automatically decompile them and click through and follow the source trees, and it's highly useful. So if you haven't used that and haven't tried dex to jar, I'd highly recommend it. It's a lifesaver. So I'm not going to go through the demo because I want to leave a couple minutes for Q&A. But here are a couple of code snippets you would use to do this type of thing. Again, available in the PDFs. You can essentially point these tools right at the APK, and they're going to give you some output. APK tool, very handy for getting resource files. I want to look at the manifest. Let's see what type of permissions are defined, what type of activities. Are there hidden activities? Are there exposed services that maybe you can interface with, and that type of thing. It is possible to do some decompiling and recompiling, right? So if the app is not super complicated and you can unbundle it, you could change some of that code, maybe Trojan the app or poison it to do some type of testing, create your own malicious version of the app to try and see what you can do with it. The important thing is that it does not always work. It will work usually for simple apps that aren't very complicated and have a lot of process flow, but a lot of times this will fail. Here's an example of how you might do that. You can use APK tool just normally, unbundle it, make whatever modifications you want. You will need to re-sign the new APK if you bundle it back up. What's interesting is that if the app's currently installed on your device and you try and deploy your malicious version, the app won't let you install it, or Android won't let you install it over top of that app, right? So naturally, just uninstall the old app, and Android goes, oh, it's signed by whoever, I don't care, as long as it's signed, and you can install your own malicious version of Facebook, right? Which is the example here. Now, there's an older version of Facebook that's worked with. I haven't been able to get it to work with newer ones. So just some resources on doing this Android hacking type of stuff. There's very good documentation on these tools, and there's some great resources. Strazier's blog is great, and you find him on Twitter. These Android forums, the XDA forums, they've been doing this stuff for a while. So, all right.
Questions?
On the Android side, I guess with the Runtime coming out, does this tool work the same on that and the developer L preview and artifact?
Yeah, so the question is, will these tools work in the new Android runtime, ART, the ART runtime, right? This came up the other day as well, and I'm not sure yet. I would have to imagine there's a different type of bytecode, so probably decompiling and this type of thing will not work. I haven't found a lot of details on that yet. It's not clear if it's going to be another Java type runtime like the Dalvik runtime, right? I'd have to imagine that there'd be some way for you to debug the apps at least, and probably the decompiling tools will catch up relatively quickly. Any other questions? All right, well, thank you everyone so much for coming to the talk. Feel free to pull us aside. We'll be here and reach out to us if you have further questions. So thank you.